Hey guys, in this lesson we would understand how to write down the Cartesian equation of a line in R2, that is 2 space. Cartesian form of equation is also called scalar form, so this can be called the scalar form of equation, and scalar is nothing but the standard form of line equation. We know a standard form of line equation is ax plus by plus c equal to 0, and this is also called scalar or Cartesian form of line equation in 2 space. There are two ways these can be determined, or there are two ways in which Cartesian or scalar form of equation can be determined. One way is by converting vector to scalar form. So we'll be given the vector equation and then we convert that to scalar form. And the second way is to write down a scalar equation, we need the perpendicular direction vector. That means we need to know the direction vector of the perpendicular of the given equation. And the notation for direction vector of the perpendicular is n. Why do we need this n vector? Because you see here a and b, these AB numbers are nothing but the point coordinates of direction vector. So a would be the x value of the direction vector and b would be the y value of the direction vector. Let's first understand how to write down a vector form of equation into a scalar form of equation, and then we'll cover up an example for this one. So for the first one, we are given a line equation in vector form that is represented as r equal to 3, negative 6 plus s, negative 1, negative 4. And we have to convert this vector equation to scalar or Cartesian form. So what all do we need to do is we would just bring out the direction vector coordinates, and that's negative 1, negative 4. We know the direction vector first x coordinate is change in x. This is change in y. We can use this to write down the slope. M without the vector line can be written as slope, and slope is change in y over change in x, or rise over run. And we know the rise is negative 4, run is negative 1. So basically slope that we got is 4. Now what we have to do is, we know the line equation is y equal to mx plus b form. In this equation, we'll substitute m as the slope that we got. For x and y, we would pick this point. So the point r0 is 3, negative 6. That's what we'll be using as x and y, and substitute this in place of x and y and solve for b. Y value is negative 6, x value is 3 plus b. We got 12 plus b equal to negative 6, and that gives us negative 6 minus 12 equal to b. So b is equal to negative 18. Therefore, our equation would be y equal to 4x minus 18. But this is slope-intercept form. We would just rearrange it in order to make it look like a standard form. We have 4x minus y minus 18 is 0. And this is called the Cartesian or scalar form of the vector equation that is given to us. So all we have to do is, whenever we are given a vector equation, we take the direction vector, turn it into slope, put it in y equal to mx plus b formula as slope, and substitute x and y for r0, and substitute x and y from r0, x and y, and solve for b. Once we get the b value, we move everything on one side in order to make it look like a standard form of line equation. Let's take up the second type. When we're given the direction vector of a perpendicular, how do we write down the Cartesian or scalar equation? So you have a line passing through a point, and a point x and y coordinates are given to you as 4 and negative 2, which has n. N is the direction vector of the perpendicular of that line. That's why it's called a normal. We have to write down its Cartesian equation. We know the Cartesian equation general form is ax plus by plus c equal to 0. Normal x and y are nothing but ab. So we would write down a as 5, b as 3, and we would use this point a for substituting x and y to solve for c. So we got 20 minus 6 plus c equal to 0. Therefore c is equal to negative 14. So the final equation that we got is 5x plus 3y minus 14 is 0 is our scalar or Cartesian equation of this question. Therefore, whenever we are given a point and we are given the normal of the line for which we are writing the equation, we just substitute the normal coordinates as a and b, and the point coordinates as x and y, and then solve for c. We isolate c and then write down a, b, and c back in the general equation, and that would give us the Cartesian form of equation. The question can be asked in the other way as well. we are given minus 3x plus 4y minus 8 equal to 0 as a Cartesian form of a line equation. We're supposed to write down the vector and parametric form of equation. Now, in order to solve for this type of question, first step that we have to follow is we change this equation to slope-intercept form. And how do we do that is we just have to isolate y. We have negative 3x plus 4y minus 8 equal to 0. So we isolate y, leave 4y on this side, move 8 on the other side, minus 3x on the other side. We get 3x plus 8. So the slope-intercept form will be y equal to 3 by 4x plus 2, because we are supposed to divide 4 with each of these. Once we get the slope-intercept form, we proceed to the second step, that is to write the direction vector using the slope of the slope-intercept form equation. We know the slope is 3 over 4. Direction vector is run comma rise, and here we are given rise over run. So run is 4, rise is 3, and this is our direction vector. Step 3 is we would write the vector equation. And for writing the vector equation, we need point R0. R0 will be taken from the y-intercept. Y-intercept is 0, 2, and the direction vector we know is 4, 3. We'll put all this information together to write down the vector equation. Therefore, the vector equation is 0, 2 plus t 4, 3. And this is our final vector equation. In the question, we were asked to write on vector and parametric equation. So the parametric equation will be x equal to 0 plus 4t and y is equal to 2 plus 3t. This is our final parametric equation. This is our final vector equation. Let's quickly summarize. If we're given an equation in standard form or scalar form or Cartesian form and we are supposed to convert it to vector or parametric form, we'll rewrite the equation in slope-intercept form. From the slope-intercept form, we'll bring out our slope and use the slope to write on the direction vector. Once we get the direction vector, then we use the y-intercept to use as R0 point. So we would have R0, we would have m direction vector. We would use both of these to write on the equation in vector form and then use the vector form of equation to write down the parametric form of equation.